Hello, welcome to the second half of Chapter 3. In the second half of Chapter 3, we're going to be focusing on matrices, and the reason that this is included in the chapter on systems of equations is because there are two other methods for solving systems of equations that have to do with matrices. So we spent the first half kind of reviewing how to solve systems of equations with elimination, substitution, graphing. We extended it a little bit to talk about three equations and three variables. We talked about inequalities. And now we're going to introduce matrices so that we can talk about a couple other methods of solving systems that we'll see later in the chapter. So if you'll think back to Algebra 1, we talked a little bit about matrices then. Today we're going to talk about how we look at data that's in matrices, and we're going to talk about some operations we can perform with matrices. But before we do that, I will come back to the vocabulary a little bit later. Let's remind ourselves what a matrix is. A matrix is a rectangular array of numbers. So most of the time we'll see like square brackets around here. This one looks a little funny. So it's a rectangular array of numbers. It always has to be a rectangle. It has rows. So this matrix has 3 rows. The rows are the horizontal parts, and the columns are the vertical sets of numbers. So every matrix has rows and columns. The rows, we always write the number of rows first and the number of columns second. So this is how we write the dimensions of a matrix, the number of rows by the number of columns. So this particular matrix would be a 3 by 3 matrix, 3 rows, 3 columns. Each individual number that is inside my matrix is called an element, or sometimes it's called an entry. You might see that as well. So each individual number is called an element or an entry. And these little numbers next to it are just some notation that we use sometimes. So A11 means it's the number in the first row and the first column. A12 means the number in the first row, second column. A13 means the number in the first row, third column. So it's always rows and then columns. All right, so if we have a matrix, one way that we use matrices is to organize data. So here I have information for 3 universities, ISU, U of I, and UNI. These are 3 different universities in the States. And each row represents a university, and each column represents tuition, room and board, and enrollment. So tuition is going to be an amount of money, room and board is an amount of money, and enrollment is a number of students. So here they're asking me to find the average of the elements, or the numbers, in column 1. So here's my first column here. Column 1 is tuition. And interpret the results. So to find the average, I'm going to add them up and divide by 3, and I get $5,935. So the interpretation of that is if I'm taking the average of the tuition for the 3 universities, the average is $5,935, which makes sense if you look at it. It's not all that, but that would be the average, or yeah. All right, another question about that same matrix. I still have the same universities, tuition, room and board, and enrollment. Which university's total cost is the lowest? So if we're talking about total cost, there are only 2 columns that have to do with money, tuition and room and board. So if I look at ISU, notice we're just adding up the tuition plus the room and board to get the total cost. I don't need to add enrollment because enrollment is number of students, and that's not going to help me. So if I add the first 2 elements in each row, I get the total cost, and if I'm looking for which one is the lowest, it would be UNI, which stands for the University of Northern Iowa. All right, same matrix, and they're asking us to interpret a little bit. Would adding the elements of the rows provide meaningful data? So if I added the tuition plus the room and board plus the enrollment, would that make sense, right? Because the numbers are only as useful to us if they make sense. That's why we have to be careful what they're representing. In this case, it wouldn't really make sense to add those together. Tuition plus room and board makes sense because that's the total cost. But adding that to the total number of students doesn't really give me a meaningful number because of the different units, okay? So we have to be careful when we're arranging data in a matrix that when we're looking at the data and analyzing it like this, that we're careful about our units and we're understanding what we're doing, not just adding numbers left and right however we want. Okay, and part D with the same matrix, would adding the elements of the third column provide meaningful data? In this case, yes, because the third column is all the same kind of number. It all is talking about the enrollment or the number of students at the university. So that would give me the total enrollment of all 3 schools. I would just need to make sure that I knew that it was enrollment of 3 schools and not just one. Okay, the next thing that we're focusing on in this section, the first was analyzing data in matrices and understanding how that works. The second is doing some operations. So we're going to start with adding and subtracting. When I add and subtract matrices, the key is that they have to have the same dimensions. So they have to have the same number of rows and the same number of columns. And all we do is add or subtract their corresponding elements. This is super easy. So here I have matrix A. It's a 2 by 2 matrix. And B is a 2 by 2 matrix, so I'm allowed to add them, and I just add the corresponding elements. So I add A plus E, and that would give me my new element here. I add C plus G, I get this element, B plus F, and D plus H. I just add. And it's the exact same thing with subtraction. Super easy. Just be careful when you're subtracting that you don't mess up your negatives. So here we're going to find A plus B if A is this matrix and B is this matrix. First of all, we have to think about the dimensions of each one. Notice that both of these matrices are 2 by 2. 2 rows, 2 columns. So I'm going to plug them in, and I'm just going to add 6 plus negative 3, 4 plus 1, negative 1 plus 0, and 0 plus 3. And that gives me my final matrix, 3, 5, negative 1, 3. Easy peasy. All right, subtraction. Here I have A minus B. Let's look at the dimensions. A has 2 rows and 1, 2, 3 columns. B has 2 rows and 2 columns. So what happens here is because the dimensions are not the same, we cannot subtract them. We cannot subtract them. Okay, I want you guys to pause and try this question. Since we just did one like this, hopefully you realize that since the dimensions are not the same, we can't add them. All right, try this one. The answer here is B. All right, so that's adding and subtracting matrices. Okay, there's 2 kinds of multiplication when we're talking with matrices. We're only going to talk about one type right now, and that's multiplying by a scalar. This is one of our vocab words for this section. A scalar is just a constant. Okay, it's like changing the scale. It's the scale by which I'm multiplying the matrix. So a scalar is just a number. Okay, a scalar is just a number. So we're not talking about multiplying a matrix times a matrix. I'm talking about multiplying a number, k, times a matrix. Super easy. It's basically like the distributive property. The scalar, or the number k, times this matrix, I just multiply each element by my scalar. So you can see this example here. If I have negative 3 times this matrix, negative 3 times 4, negative 3 times 1, negative 3 times 7, negative 3 times negative 2. And then I simplify. So let's look at an example. If A equals this matrix, this is a 3 by 2 matrix, 3 rows, 2 columns. I want to find 2 times A. All I have to do is multiply that matrix by 2. I multiply every element by 2 and simplify. And that's your final answer. So what you have to be careful with here is your arithmetic. All right, you guys try this one. Find 4A. Hopefully you got B. 4 times every element of matrix A gives me this result. And just a reminder, this is a 2 by 3 matrix. 2 rows, 3 columns. Okay, we have a few properties of matrix operations that we can get from this section. So when I'm talking about matrices here, not just real numbers, but matrices, square arrays of numbers, they follow the commutative and the associative property of addition. So I'm allowed to add matrices in any order. A plus B is the same as B plus A if A and B are matrices. The associative also works. I can add A and B first and then add C, or I can add B and C first and then add A. So I can add different groups. As long as I'm adding everything, it's still going to be the same. The distributive property also works for a scalar, or for a constant, and it works from the left. So if I put my constant to the left and I distribute it to matrix A and matrix B, that's fine. Or I can do it from the right and distribute it to matrix B and matrix A. So distributive property works with scalars, with constants. In a future section, we will see that when I multiply two matrices times each other, things change a little bit. Okay, let's try this example here. Sometimes we'll have more than one operation in one problem. So here they give me matrix A, matrix B, and I need to find 4 times matrix A minus 3 times matrix B. What we're going to do is perform the scalar multiplication first, just like our normal order of operations, and then we will subtract. So we're going to take 4 times matrix A, which is here, and 3 times matrix B, and then I have this subtraction. So notice, be careful here. What they did here was they distributed the 3 and they left the negative, or the subtraction, between my two matrices. If you distribute the negative 3, you would have to change this to addition because you're only going to use the negative once. So you distribute, simplify, and then you do your subtraction. 8 minus negative 6, 12 minus 3, and so on. And we get our final matrix of 14, 9, negative 4, 3. All right, here is one for you. The answer is A. So you should have taken 5 times matrix A, 2 times matrix B, and then subtracted. All right, actually I think we're going to stop there. We're going to look at some more examples in class tomorrow, but this is the end of the video for this section. Make sure if you have any specific questions that you jot them down and bring them to class. See you there.